Hey everybody, this is Patrick. I want to show you a quick video on how to fine-tune Wav2Vec. So we're going to head to the blog post and I'm going to open the Colab directly because that's what you're going to use to fine-tune your model. And yeah, once you're there, the first thing you should do is to make a copy because otherwise it's not going to be in your personal Google Drive and you cannot save the model weights. So we click on Save a Copy in Drive. And this should be open in
Kapanma saati yaklaştığında fiyatlar düşüyor.
All right, great. The first thing you should do here then is to probably give it a better name, something that relates to your training. So I decided for the video that I'm gonna train the Wav2Vec model in Irish. So I'm gonna switch that.
Kapanma saati yaklaştığında fiyatlar düşüyor.
And cool. Now we're going to go through the Colab real quick. So it's very helpful if you actually read all the text here to better understand how the model works. But I will skip that to just show you the essentials. So first thing to do is to install the libraries right here. We need datasets, we need transformers, and then we need 3 other libraries to process the audio and to do the scoring in the end. The very first thing you should do is actually to pick a language you want to train your model on. So we head over to the Common Voice website where you can see all the languages that are available. We have 60 languages here, ranging from a very high resource like French to very low resource languages like Welsh, for example. For this notebook, I'm going to choose Irish, but you can choose whatever language you want, essentially. Ideally, you choose a language you are a native speaker in because it can help you to have a better data processing pipeline in the end. All right, so you should focus on the version field here and then copy the language code, which is always the prefix before the underscore. For Irish, it's GA-IE. So we take that and paste it in the second cell where we load the Common Voice data set. Great, okay, we've installed the libraries here. Now we can load the data set. It really depends on the dataset size, how fast this command runs, but for our case here for Irish, since it's just 150 megabytes, it's going to be very quick. Cool. The next step is then to kind of remove all the unnecessary data you don't need. So Common Voice has also data about the age, the client ID, and the votes, how good the data samples are, and some other things. But all you need is essentially the auto path and the transcription, which is called sentence. Those are not included here. That's why we keep them and don't remove them. So we click on the cell, run it, and we can see afterwards that all that's left for our data set is just the path and the sentence. That's all we need. Great. One other thing that's very important here is you can see that we simply put the training data and the validation data together to form the training data set. The test data is just going to be used as our validation data set during training. And the reason why we do this is because there's not a lot of data for most low resource languages. So every data set split we can get, we should include in the training data except the test data, because that's the data we're going to evaluate the model on. And obviously we can include this in the training data. But you should also look out for other data sets of this particular language on the internet and try to include it. It's probably going to help your model to get a better final score on the test data. Great, all right. So we pre-processed we load our data. The next thing is to actually take a look at some data samples. So we do this here. And yeah, we can see that, well, we have pretty much the normal letters of the alphabet and some special characters like the dot here, like a comma here. And we can also see that it's a mixture of capitalized and lowercase letters. So our model doesn't need to know the difference between a capital M and a lowercase m. So we try to normalize every data sample to only include lowercase letters. Also, we're going to remove all those special characters because they don't really help us for the final transcription. It's very hard for a model actually to transcribe a chunk of speech to let's say a comma. So in order to help our model learn better, we're just gonna remove those. Cool. So here you can define all the characters you want to remove of the data set in Excel. I think those are leftovers from the Turkish demo, but we're just gonna run this for now and see what happens. So remove them, then apply the mapping function to both data sets, the train and the test, and again look at some random elements. Okay, now we can see that we only have lowercase letters, which is good, and we removed the commas and the dots, and it looks like there are no more special characters, which is great. So this looks fine. Then we can go to the next step and create the vocabulary. It's very important to create the vocabulary because the vocabulary is going to decide also how long or how large your language head is, which is going to be put on top of your pre-trained model. All right, so the next function is going to extract all relevant characters from the whole data set. So you can see here that we join all data samples together into one big string and then apply set function over it. So that everything that is left is just the single characters. Okay, we apply this function again to both data sets with a very convenient map function and then merge those two vocabs. So the vocab train and the vocab test to one big vocabulary. All right, let's take a look. Okay, cool. We can see that we have about 37 characters on vocabulary, but there's still some special characters that should probably be removed. Yeah, it's very hard for a model to classify speech to an open or closed parenthesis, so we should remove those. The star symbol also doesn't make too much sense here, or isn't really helping. And those letters don't help either that much. So we're gonna include all of those again in our remove function above. So you can just go up here and include them. And then we're gonna just apply it another time to clean this up as well. It's actually a good idea to just run first as it is, and then in the second step, kind of refine your vocabulary by removing additional special characters. So we do this here now for 5 characters. This as well. And the last one should be this somewhat weird apostrophe here. So copy that and include it here as well. Great. So now we can just run it again. And let's see how our new vocabulary looks like. Okay, again, like our sentences looks nice. They look like sensible transcriptions, and we create the vocabulary again. All right. Okay, now it's much shorter, which is good. So now we only have, I think, around 30 characters left, or 31. And they all look very reasonable. So we got all the letters of the alphabet and then some special, actually without the Z, which means that no Z is found in the training and test data. And then in addition, we have 5 special letters which seem to be unique to the Irish language. So this looks very good. Then, yeah, we can add some special tokens, like the unknown token. It's always important that a model can classify tokens it doesn't know to something. So we should always add an unknown token to our tokenizer. And we're also going to add the padding token, which is very important if we do batch training, which we're obviously going to do. And lastly, we also it's very important to keep the space character actually. So we can see that we kept this here. And that's a very important token because it's important for the model to learn where it has to separate one word from the other. So we give it a special character here, which is this dash, and add it to the vocabulary. Cool. Okay, our final vocabulary size is 33, which is reasonable. And now we have created vocabulary and save it under a JSON file. And we can now load the tokenizer with this vocab. So we first import the Wav2Vec2 CTC tokenizer, insert the path to the vocabulary we just created here, and then add some special characters. So we added those to the vocab already, but we also need to say that those are special characters. So that the model knows, for example, that the ung token we added to the vocab above is actually gonna be used in the function of the ung token of the tokenizer. All right, so it's created. And yeah, this is actually already most of the data processing. What is really important here is that you kind of try to remove as many special characters as you can where you think that the model has a hard time classifying speech to those characters, because you don't need to, you need to have them in the end. This often includes the comma, but also the dot. All right, great. Then next, we're gonna create the feature extractor. So the feature extractor is the very, very front end of our training pipeline. And it takes the raw radio, the raw audio waveform, and transforms it to a PyTorch error, which is understood as the input format of the model. This is normally pretty easy. You don't really have to change this function here, because all Wav2Vec models work with a sampling rate of 16,000. The feature size is always going to be 1. The padding value is always going to be 0. And we should always normalize, and we should also use intentionalize. So this cell doesn't really need to be adapted depending on your language. Okay, great. Then next, we're gonna wrap both the feature extractor and the tokenizer into a processor, so that we only need one class during the training pipeline. Or you can already see that the Colab pops up a window which asks me whether I'm active. This is going to happen more often, but I'm going to show you a hack later how to avoid this. Okay, great. Let's create a processor. And yeah, now you should mount the processor to your Google Drive, because you want to save everything that you've created to not lose any data if the Colab crashes. Okay, it's very easy actually. Just include those 2 lines. Then you go to this link, just sign in. So I'm going to sign into my Hugging Face account here, and then there should be a code that you can just copy and insert it here. After you've done that, you've mounted your Google Drive essentially to the Colab, which means that you can save anything you want in this Google Drive. So the first thing we're going to save is our processor. We give it a different name now, which is going to, instead of Turkish, it's going to be Irish, and yeah, we'll leave demo. But you can call it whatever you want. So we save that, and feature processing is done now. Also remember, if you rerun this Colab and you've done this part once and you're happy with this part, you don't need to rerun it. In the next time you run the Colab, all you need to do is you can simply load the processor from your drive, because you've already saved that. So all you need to do is you write processor equals Wav2Vec processor, and then you use the famous Hugging Face from pre-train command to load it. So you can do this right now as well. Cool, that worked. So we don't really need to do this part anymore again, because we have the processor saved. Great. The next step is now to use the processor to actually process the data. So let's take a look at our common voice training data set. We removed all columns except the path, which is a path to an audio file, MP3 in this case, and the transcription, which is here. Great. Then we can import torch audio to actually load the audio file into memory. So we're going to load a file to a NumPy speech array here, or actually to a torch speech array here, and then save it in the data set under the name speech. We're also going to save the sampling rate and rename sentence to target text. So we'll run this on both data sets, both the training and the test. This is usually doesn't take too much time. So here you can see it only takes 10 seconds, which is again because our data set is quite small. All right, okay, so this should be finished soon for the training set. And the test set is only half the size, so that also doesn't take too much time. Great. And the next step, we now have to resample the speech files, because Common Voice was sampled at 48 kilohertz, while Wav2Vec2 was pre-trained at 16 kilohertz. So we need to downsample the training data to 16 kilohertz. Otherwise, the model is not going to understand it. So this function does that. It uses the libRosa library to resample and applies it again to every sample of the library of the data set. So we apply the mapping function to both data sets again, and we also going to use some multiprocessing here. You can try to use higher numbers like 8. It might be faster, but I think 4 is normally fine. This step normally takes most of the time. As you can see here, it takes 1 minute for small data sets, so it's not uncommon that this can take up to 10 minutes for bigger data sets. But then in the meantime, I can jump back to the model a bit and explain how the fine-tuning works exactly. So let's go back here. So Wav2Vec is essentially just a feature extractor, which is a stack of convolution layers, followed by a transformer block, which is a stack of transformer layers or self-attention layers. And then on top of that, you have an LM head layer, which classifies each speech chunk to one output token. We define letters at output tokens, so it's going to classify each speech chunk to one letter. And then combined with the CTC algorithm, you get your final transcription. Now the pre-training happened only with the feature extraction and the transformer part, so there was no LM head, as you can see here. What happens now is that we're going to add a randomly initialized LM head on top, and we're going to fine-tune this. This is also this is important to remember, because the checkpoint we load actually doesn't contain any weights for the LM head, so those are always going to be randomly initialized. Which then again means that you need to define a vocabulary to define the size of your output layer. Otherwise, that's not going to work. So it's very important that you do the vocabulary creation before actually loading your pre-trained model. All right, let's look at where we're at with our downsampling. Okay, and you can see that we're almost done. So it took a bit more than a minute for a small data set. It can probably take up to 10 minutes for bigger data sets, but it shouldn't be a problem. Great. Then the next step is just to run some sanity checks. The first one is that we're going to listen to the audio. I don't speak Irish, but that does sound good to me. If the sound you hear is stretched very, very long, so that it sounds very slow, or it's way too fast, then might be a problem. Then the downsampling might have not worked correctly, or if it just sounds weird, then there could be a problem. So that's always a good sanity check, to just listen to the downsampled audio sample. The second sanity check is just going to be to take a look at the data. So we see that our target text, our transcription still looks good, so our good label. Our input array is a 1D shaped array, which is also good. And the sampling rate is 16,000, which is correct for Wav2Vec. Okay, great. Then next, we're going to pre-process our data set in the final step, so that the output is recognized by the model, which means that we need to define an input values vector and a label vector. So we can define this here. And what I do here is I use the processor class we instantiated before. First, in the normal context, you can see there's no context manager here, to just pad the speech to have the same length and to be in the format of a PyTorch array. The second step is to encode the target text into kind of label IDs. So we do this by wrapping the processor into a target processor context right here. Then again, we can apply this function to all samples in the data sets. We do this here, both for the train and the test data set. And this also shouldn't take very long for small data sets, just 10 seconds. And then we can go to the training. So I want to keep myself short here as well, because there's a lot of things you have to do for the training, and the best idea is probably to read up on the documents on the transformer docs. But in short, we have to define a data collator, then we have to define a evaluation metric function, then we have to load the pre-trained checkpoint, and finally define the training configuration. So the data collator, I put the whole code for the data collator here, and you don't need to change anything. So you can reuse it. If you want to understand how it works better, then I recommend to look at the docs or the example, which is here, and to just really read the text here throughoutly. And then we can instantiate the data collator and load our metric. Great. The metric is going to be word error rate. For some languages like Chinese and Japanese, you might want to use a different error rate, like character error rate. But I'm going to post more about this later on the Slack channel. Great. Then next, we're going to define our compute metrics function that we're going to plug in to our trainer. And what we do here is we kind of decode or redecode our encoded labels to strings. So that's done here. And also we make sure that our ignored labels, so all the padding IDs that were ignored by -100, are given the padding token again, so that we can correctly compute the word error rate of both strings. Great. All right. Next, we're going to load our pre-trained model. So we're always going to use this pre-trained checkpoint, which is called Wav2Vec large XLSR-Wav2Vec2. And as I said earlier, this checkpoint does not contain any weights for the LM head. So that's what you have to fine tune. Those parts also don't need any changes. So we're always going to use gradient checkpointing in the Colab just to save memory. I think a loss reduction of mean should always work. It's very important that you add those two lines. One, because the model needs to know what token is actually used as the padding token. Because this token also corresponds to the CTC, kind of skip token or empty token. And then very important is also that you define the correct vocab size. So the vocab size equals the length of the tokenizer. So all the tokens we defined above. As I said earlier, the vocab size defines the length of your output layer. So those things absolutely have to match, otherwise the training is going to crash. Now those parameters are hyperparameters you probably have to tune for training work. I used those 5 parameters for the Turkish demo because it worked well, but I think I needed to try out different combinations. I would just suggest to try different things. So normally layer drop, mask time probability are things you don't have to change much. But the other dropouts you can play around with and just see what works best for you. All right, next we want to freeze the feature extractor because this has already been learned enough during pre-training, and it's also written in the paper that we should not fine-tune this part anymore. So as a short reminder, the feature extractor is the part below here. Great. And then finally, we have loaded the model right here. So you can see again that it says the LM head was randomly initialized, which is what we expect, and which is what we're going to fine-tune now. And then in the final step, you define your training arguments. So most arguments, again, you can leave. We should make sure the output here corresponds to the dir the directory that you defined above. So I think I called it my drive Wav2Vec2 large XLSR Irish demo. So we use the same here so that all the model weights that you save during training are actually going to be saved here. These parameters here, you don't really need to change as well those because we just try to have a batch size as high as possible in the Colab, and 16 is already pretty high. By using gradient accumulation, we have an effective batch size of 32, which also seems to work well across languages. We should always group by length, which means that our batches have samples inside that are more or less all of the same length, which is very important for efficiency. We should train in half precision just to make it faster. And then those things you might want to adapt. So for lower research languages, we can actually go up much more with training epochs because we only have 1,000 data samples. Save steps really depends on you. I mean, if you want to, in your early tries, it might make sense to save a lot. So maybe just every 50 steps you want to save. And also we're going to evaluate every 50 steps and log every 50 steps. But those parameters you can adapt. It just means how often you save your model and how often you run the evaluation. Obviously, the more often you run it, the slower your training is going to be. Warm-up steps and rates are other hyperparameters that are important to tune. I don't know at all whether this learning rate works well for Irish, so I'll just try it out, and then if it doesn't work, increase it or decrease it. And warm-up steps also depend very much on your dataset size. So because you only have 1,000 samples, I'm actually going to reduce this to just 100. Great. Okay, so let's log those in and create our trainer. Okay, compute metrics undefined. That's probably why, because it didn't run the function. So let's make sure we run all cells before actually creating the trainer and run it again. Great. It worked this time then. And okay. This seems to take some time. Now it's finished. And then finally we can start training. The problem in Google Colabs is that you might get some timeout errors because Colab is going to ask you regularly whether you're still active. If you're inactive for too long, it's just going to shut down the training. So an important hack to prevent this is to make your JavaScript code in your console ping Google Colab. And what you can do is to just insert the JavaScript code here into the console of your browser right here. Because this way you set a program that's going to ping Google Colab every 60 seconds to make sure that the training script can actually run for, I think it can run up to 12 hours in a free Colab. And if you have a Google Colab Pro, it can run up to 24 hours and you probably don't need this. But if you have a free version, it's actually very important that you use this function to make sure your training keeps running. Great, all right, the training started now. You can see that we have a total of 2,880 update steps. Yeah, this should be enough. This should be enough. It literally means that we use the data 90 times. And yeah, you can see in the end, I mean, just from the loss curves, whether you should further train or not. All right, great. That's pretty much it. We can take a look at the rest here, but this is just for evaluation. It was mostly for demonstration purposes. So the important part is what I've explained so far. You can see now that the active session window popped up, which is because of the JavaScript command I just inserted, which is good because it helps to prevent this caller from crashing. All right, great. And one last thing you should always check when you train is that the code was actually, that the models were actually saved in your Google Drive. So you can see here, my Google Drive, I have now an Irish folder, which was just created by me because I mounted my Google Drive. And I don't have any model weights yet, but I have all the configuration files I need for my tokenizer and my preprocessor. So it's very important that you use the mounted Google Drive folders for both the feature extractor, tokenizer, and also for your output here during training. All right, I'm just going to stop this. I'm sure that someone else will train more on Irish. And I hope this video helps you. If you have any questions whatsoever, please write us in the Slack or use the forum.